Okay, so today we're going to be looking at Unit 6, Day 1. We're finally getting away from triangles. Praise the Lord. We're getting away from triangles to an extent. We're going to have to deal with them a little bit, but not like we were. So for this unit, we're going to look at kind of polygons in general for today. And then the rest of the week, or unit, I should say, we're going to just look at parallelograms. But let's get through today first. So a polygon is a closed plane figure formed by 3 or more line segments. Each segment intersects exactly 2 other segments only at their endpoints, and no 2 segments with a common endpoint are collinear. So down below we have several examples of polygons, and then we've got several that are not. So let's kind of think about why they're not. So this first one, it has a rounded side. It can't be rounded. There has to be a line. A line is straight. Next one, we've got this little tail out here. That makes it not a polygon. Here, they're not connected. They're open. Of course, this one is 3D. Polygons are not 3D. They're only 2D. And then on this one, they cross. So they have to be it's got to be a 2-dimensional shape with straight sides. If that happens, then it's a polygon. So each segment that forms a polygon is a side of the polygon. The common endpoints of 2 sides is called a vertex. And then the segment that connects any 2 non-consecutive vertices is a diagonal. And so when we name a polygon, of course, you know the normal. There's triangles, there's rectangles, there's squares, pentagons, hexagons, octagons. You've heard of those. But when we name them by the number of its sides. How many sides does it have? And we're going to use this list over here. These are our most common ones. You will have to have these memorized for the test. So a 3-sided polygon. That's the one we've come to love to hate. A triangle. 4-sided, that's a quadrilateral. 5-sided is a pentagon. 6-sided is a hexagon. 7-sided is a heptagon. 8-sided, that's your octagon. Non-sided is a nonagon. Almost sounds like you're saying 9-agon, but it's non. 10, decagon. Just like there's 10 years in a decade, 10 sides in a decagon. To me, 12 is the most fun to say. Dodecagon. Dodecagon. And then the n, if they had just any number of sides that's not listed here, we call it an n-gon. So those are the different sides or different names for polygons based on their sides. Okay, first example. We have to tell whether the figure is a polygon. If it is, then we have to name it by how many sides it has. So what do y'all think on this one? All straight sides? Does it fit our definition? Yes. So that means this is a, let's see, it's got 1, 2, 3, 4, 5. So we would say yes. This is a pentagon. What about B? We cross in the middle. So is this one? No. Not a polygon. What about the next one? Well, they all have straight sides. They all meet only at their endpoints. So I can't find anything to disqualify it. So let's see how many sides it has. So I can't disqualify it, so I'm gonna have to say yes. And then let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So an 8-sided polygon is an octagon. Okay, so all sides, if all sides are congruent, then we have an equilateral polygon. Almost sounds like we're talking about an equilateral triangle. Well, that's how it got its name. If all the angles are congruent, we have an, here's this word that makes some of y'all squirm because y'all think I made it up, equiangular polygon. Now, what if both of these happen? And what I mean by that is, let's say all sides are congruent. So what if they both happen? All sides are congruent and all angles are congruent. What happens if both of those happen? Then we have what's called a regular polygon. A regular polygon is both equilateral and equiangular. If a polygon's not regular, then it's called irregular. Okay, and then we have a thing called concave. So a polygon is concave if any part of a diagonal contains points in the exterior of a polygon. So if you try to connect two corners that aren't next to each other and you cross outside the shape, then it's concave. If it is not concave, then it is called convex. Now, a regular polygon will always be convex. We can't go backwards and say a convex polygon is always regular. We cannot say that. But if you say it's regular, then you have to say convex. Let's look at an example with all of this in mind. So we have to tell whether first it's regular or irregular, and then whether it's concave or convex. Let's look at this first one. First, check your sides. Are all your sides the same? Oh, I see this side is congruent, but then these two are different, and I know that because there's two different marks there. That means the sides here, the one I circled in black and the one I circled in red, those are not the same. So we can't say regular here because they're not all the same. This one is irregular. Now for concave or convex, to say concave, it has to look like somebody pushed something in. Did I get mad and push this side in and indent it? No. All the sides are pushed out, so this is considered convex. Let's look at B. Let's see, all my sides are the same. All my angles are the same. So is this one regular or irregular? Ah, this is regular. Everything matches. If it's regular, it has to be what? Convex. Regular has to be convex. Okay, next one. So my first check all my sides. All the sides match. We're Gucci. Then I go and check all my angles. Now notice between every two sides, there's an angle. So I've got this angle here, but then I've got this angle right here. Are those two the same? No. So this is irregular. Now, on this one for concave or convex, Does it look like I got mad and I kicked some sides in? Yeah, it does. If I connect these two corners, look what happens. I have to go totally outside the shape to connect them in a straight line. So this is what it means by concave. It's like someone got mad and just took this side and boom, punched it in. That's concave. Okay, so this is geometry, so we still have to deal with angles here to find the sum of the interior angle measures of a convex polygon. Notice we're saying convex, not concave. Convex. We need to draw all possible diagonals from one vertex of the polygon. So on the triangle, are there any diagonals I can draw? No. What about a quadrilateral though? If I start in this vertex, the only corner I haven't connected to is this one over here. So I'm going to connect to it. Then I'm going to do this pentagon. If I start at this one, I want to connect to, oh, that's not a straight line. I want to connect to that one. So I've done that one. I can connect to that one and that one. So I've connected to every point here. We'll do a hexagon. Start here. I've connected to that one with the side. I just drew to connect to this one down here. Connected to that one now. And boom, I'm connected to that one now. So I'm now connected on all these shapes. I started at a point and I connected that point to every angle there. And what do you notice they all make? They all make triangles. So I said we're done, but we're not done with triangles. Let's see if we can figure something out here. So let's focus on the triangle. How many sides does a triangle have? 1, 2, 3 sides. How many triangles is inside that one? Just one. And so the sum of the interior angle measures, well, there's only one triangle. So if I said 1 times 180, that would get me what? 180. One, two. So if I wanted to find the sum of the exterior angles, since I have two triangles stuck in there, I can do 2 times 180, which gets me 360 degrees. Now for a pentagon, how many sides do I have on a pentagon? 1, 2, 3, 4, 5. Okay. How many triangles do we see? 1, 2, 3. Since I have 3 triangles to get the sum of the angle measures, I can do 3 times 180, which gets me 540 degrees. Then we have the hexagon. How many sides does it have? 6. But how many triangles? 4. So to get the sum of its angle measures, I'll do 4 times 180. Which would get me 720 degrees. And then they asked me about an n-gon. Well, an n-gon has n sides. Now you may be thinking, well, how can I figure out how many triangles it has? I can't draw it. Well, let's see if we can figure out a pattern here. How did I get from 3 to 1? I subtracted 2. What about 4 to 2? Subtracted 2. 5 to 3? Minus 2. 6 to 4? Minus 2. Oh, so if I stick a minus 2 here, what would that get me for number of triangles? N minus 2. And then notice here, to get the sum of the angles, I just did how many triangles I had times 180. I have n minus 2 triangles, so I could say n minus 2 times 180 degrees. There we go. We just did a generic n-gon. And that actually leads us to the polygon angle sum theorem, because this one right here is actually what goes in this blank. The sum of an interior angle measures, the sum of the interior angle measures of a convex polygon with n sides is n minus 2 times 180 degrees. Now, there's different kinds of questions they could ask you about this. Different kinds of questions they could ask you. First thing they could do is ask you to find the sum, just like we did up above, the sum of the interior angle measures of a convex octagon. How many sides does an octagon have? N equals 8. We just want the sum of the angles here. That's what this theorem tells us. We just straight up plug 8 in. So 8 minus 2 times 180 degrees. That would be 1080 degrees. B, find the measure of each interior angle of a regular nonagon. Well, let's see. Nonagon has how many sides? 9. Okay, so let's do like we did above. 9 minus 2. Times 180. It's going to get us 1,260 degrees. Now, does it ask me for the total, for the sum? No, it asks me for each angle. Each interior angle. Sorry, I need to highlight that too. Each interior angle. Well, how many angles do I have? 9. So I have to divide this 1260 by 9 to get each angle. $12.60 divided by 9 is 140 degrees. So there's that one. Okay, we're getting down to the end finally. So in the polygons below, an exterior angle has been measured at each vertex. Find the sum of the exterior angles. So they just want us to add these up. So here goes it. 147, 132, and 81. If you add them all up, what do you get? It's going to give me a 0. Carry your 1, so that's 5. 8. That's going to be 16. Carry your 1. Okay, this first one I'm getting 360 on. Let's try the next one. So I have 111, 41, 43, 55, and 110. Let's see what I get here. That's going to be 10, carry your 1, 2, 6, 10, 15, 16, carry your 1. Oh, wait a minute. Hold up. I got 360 there. I got 360 here. But I have different shapes. Well, that's because of the polygon exterior angle sum theorem. So the sum of the exterior angles, one angle at each vertex of a convex polygon, is always 360 degrees. Okay, last example. Find the value of A in polygon RSTUV. Well, what do we notice about all of these angles? They are exterior. And if we add up all the exterior angles, what should they add to? 360. So let's add them up. 7A plus 2A plus 3A plus 6A plus 2A equals 360. So total, that gets us 20A equals 360. Divide by 20. And you get A equals 18. OBKB, that's the notes. So we survived day 1 notes. Stay tuned for the guided practice.